Hi guys, hello everyone. This is Saurav here, and welcome to the Vedantu VOS channel. In this session, we are going to discuss a certain type of organic reaction which involves migration to an electron deficient oxygen. आगे कुछ वीडियोस में हम माइग्रेशन टू इलेक्ट्रॉन डेफिशिएंट कार्बन भी देखेंगे एंड माइग्रेशन टू इलेक्ट्रॉन डेफिशिएंट ऑक्सीजन भी इलेक्ट्रॉन डेफिशिएंट नाइट्रोजन भी देखेंगे. These migrations are very important from the IIT JEE, INCHO, NSEC perspective, and it would be good to consolidate such migrations in one place. Hence, this video will be the first of them. So, चलिए आज का सेशन स्टार्ट करते हैं और आज के सेशन में हम तीन इंपॉर्टेंट रिएक्शंस डिस्कस करेंगे in which migrations take place to an electron deficient oxygen. हमेशा याद रखो कि whenever these migrations are, you can think of them as nucleophilic rearrangements. Okay, ये nucleophilic होता है because when it is an electron deficient, तो electrophile will not go to oxygen. It has to be a nucleophilic species which has to go to oxygen. Okay, so our first mechanism that we are going to discuss today, which involves migration to an electron deficient oxygen, is the Baeyer-Villiger oxidation. Baeyer-Villiger oxidation is a method of converting a carbonyl compound, I would say ketones, to esters. Carbonyl compound to ester conversion is done by Baeyer-Villiger oxidation. What happens in a Baeyer-Villiger oxidation? So what we do is we take a ketone and we treat it with a peroxy acid. Okay, अब देखिए, you treat a ketone. What kind of a ketone? You can take open chain ketones or you can take cyclic ketones. किसी भी तरह का कीटोन आप ले सकते हैं एंड दीज कीटोन्स ओपन चेन कीटोन्स और साइक्लिक कीटोन्स एंड you can treat it with any kind of a peroxy acid like trifluoroacetic acid, metachloroperoxybenzoic acid, which is also known as MCPBA, परबेंजोइक एसिड. और इससे क्या होता है कि ये कीटोन एक एस्टर में कन्वर्ट कर जाता है and this per acid turns into a carboxylic acid. कुछ simple ideas, मतलब कुछ simple examples मैं आपको दे देता हूं. For example, if you take CH3 C double bond OCH3 and you treat it with MCPBA, you will be getting CH3 C double bond O OCH3. Next, if I take PH C double bond O CH3 and I repeat the same reagent MCPBA, it will be CH3 C double bond O OPH. याद रखिए, metachloroperoxybenzoic acid, the structure is like this: COOH, and this is, sorry, there must be more oxygens, so you should be having 3 oxygen at the carbon atom. Okay, this is metachloroperoxy. You can see there is a peroxy linkage. If you take a cyclic ketone like this, cyclopentanone, and you take MCPBA, then you will get this species. Let's try and understand the mechanism of this particular reaction. So, for the sake of convenience, मैं एक acetone molecule ले लेता हूं. This acetone is made to react with, let's say, PHC double bond O OH. So initially, the very first step of the reaction would involve conversion of this ketone to a protonated ketone. क्योंकि acid present है, so ketone will convert into a protonated ketone. Okay, perfect. And you will get pH CO3 minus. Next step is this CH3 C double bond OH positive CH3 plus O C double bond O pH. This will attack over here, this will come over here, and you would be getting CH3 C OH CH3 O C double bond O pH. Okay. Now इसके बाद का जो स्टेप होता है ना, the step after this is the rate determining step. The step after this is the rate determining step. What actually happens is these electrons come over here. This one moves to this oxygen. This one comes over here and this one goes out. So देखिए ये first step है movement का. This is second, this is third, and this is fourth. In doing so, we will be getting CH3 C double bond O CH3 plus pH C double bond O minus, which will be eventually bonded to H plus. Is that clear? So you have gotten your ester. You have gotten your ester. अब ये जो step है, in this step, what group will migrate will depend on the why are we saying that it is a migration to a electron deficient? क्योंकि अगर आपने सिर्फ step 3 को observe किया, then you can think of it as that this bond is being broken and this oxygen over here, this oxygen gets a positive charge. However, that full-blown positive charge is never observed, but it can be speculated like that. Okay, it can be speculated like that. Is that clear? So, अगर हमने यहाँ पे observe किया कि which group migrates to oxygen in unsymmetrical ketone. If it is a symmetrical ketone, then anything can migrate, but if it is an unsymmetrical ketone, then what will migrate? So this migrating tendency is identified by something known as migratory aptitude. Okay, it is identified by something known as migratory aptitude. So यहाँ पे for Baeyer-Villiger oxidation, the migratory aptitude is this. The migratory aptitude is an experimentally calculated feature, so please do not try to make a lot of sense for this. Usually होता क्या है कि when you are migrating a group to an electron deficient system, then उस group पे जो migrate कर रहा है should have a very large amount of negative charge. That means if there are electron donating groups, then it will migrate faster than compared to something which has electron withdrawing groups. So मैं idea दे दे रहा हूँ आपको. 3 degree alkyl will have a higher migratory aptitude than 2 degree alkyl, which will have a higher migratory aptitude than benzyl, which will have a higher migratory aptitude than 1 degree alkyl, which will have higher migratory aptitude than cyclopropyl, मिथाइल सबसे बाद में आ जाएगा। एंड जो माइग्रेट करेगा, प्लीज रिमेंबर, if there is a unsymmetrical ketone like this R1C double bond OR2, then the one which has higher migratory aptitude will have a new oxygen inserted between it and C double bond O. क्लियर? सो इस तरह से चलता है। ये हो गया एक सेट ऑफ माइग्रेटरी एप्टीट्यूड्स। दूसरे सेट ऑफ माइग्रेटरी एप्टीट्यूड्स ऑफ एराइल सिस्टम्स को लेके आप बना सकते हो। इफ अ एराइल सिस्टम हैज एन इलेक्ट्रॉन डोनेटिंग ग्रुप, EDG is electron donating group, then it will migrate faster than just plain aryl, which will migrate faster than aryl system with electron withdrawing group. EWG. ओके, तो इस तरह से चलता है ये। परफेक्ट। चलो कुछ एग्जांपल्स देखते हैं। तो अगर मैंने ये लिया CH3 C डबल बॉन्ड O CME, then this has higher migratory aptitude. So if you react it with MCPBA, then the product form will be, जिसकी migratory aptitude ज्यादा है उधर उस alkyl group and carbonyl के बीच में ऑक्सीजन एंटर कर जाएगा। double bond O, and here is a methyl. So this is a, you can think of this as a 2-degree alkyl, this is a 1-degree alkyl, MCPBA, you will get this. Okay, next another important feature is, अगर ये alkyl group जो migrate कर रहा है is optically active, then for example something like this, something like this. This will have higher migratory aptitude, higher for this one. So this is chiral, and if this is optically active, whatever is the stereochemistry of that entity, that stereochemistry will be retained. Okay, so if this is optically active, this will also be optically active. ठीक है, नेक्स्ट मान लेते हैं कि आपके पास इस तरह का एक कंपाउंड है, let's say PHC double bond O ME, and this is O18, and this is being treated with MCPBA. Always remember, if this carbonyl oxygen is labeled, that carbonyl oxygen persists within the molecule and it will not be lost in the course of reaction. ये हमें ऐसा मिल जाएगा. Okay? Perfect. Next, मान लेते हैं कि आपके पास इस तरह का के दो कीटोन्स आपने लिए हैं एंड दो कीटोन्स के मिक्सचर को you have subjected it to Baeyer-Villiger oxidation. Then remember, CH3 C double bond O O CH3 will be formed. ET C double bond O O ET will be formed, but CH3 C double bond O O ET or ET C double bond O O CH3, these will be not obtained. These will not be obtained. इसका मतलब Baeyer-Villiger oxidation doesn't give crossover products. This is very important. So मैंने आपको कुछ examples दे दिए. Let's look at certain cases जहां पे Baeyer-Villiger oxidation हो रहा है. How do I identify कि किधर insertion होना चाहिए? So what I will do is, ये जो कार्बन है, this carbon looks like it is 1, 2, it looks like a 2 degree. This one looks like it is connected to only one carbon, 1 degree. तो ऑक्सीजन यहां एंटर करेगा. ओके, अब देखिए ऑक्सीजन इधर एंटर कर गया है. ओके, नेक्स्ट, this is again connected to 1, so this will, I will consider as 1 degree. This is connected to 1, 2, this is 2 degree. So oxygen will insert over here. Can you see this? So this bond is removed and we create something like this, and that is what is obtained. This carbon is 1, 2, 3 degree. This carbon is 2 degree. So we will insert an oxygen over here. Okay, this carbon is 1, 2, 3 degree. This carbon is phenyl, which has a higher migratory aptitude. 3 degree has more than phenyl. So oxygen insertion will take place over here. Okay, this one is also pretty simple. ये दोनों तरफ एक ही जैसा है, तो किसी भी तरफ आप ऐड कर दो, you will get the same product. Okay, you'll get the same product. So this was about Baeyer-Villiger oxidation. Let's move on to the next type of reaction, which is known as the hydroperoxide rearrangement. Whenever you take a hydroperoxide, what is a hydroperoxide? A hydroperoxide is an organic compound in which contains a COOH unit. And these OO are not like this one. This is also a COH unit, which is a carboxylic acid unit. But over here, this COH unit is very different. This COH unit is the one which contains a peroxy linkage. So, if there is a peroxy linkage present within the organic compound, it will undergo reaction presence of H plus to result in a nucleophilic rearrangement to an electron deficient oxygen atom. Okay, electron deficient oxygen atom. Let's try to understand the mechanism. This oxygen takes up H plus. मैं यहाँ पे लिखने की कोशिश करता हूँ. So let's say Me3COOH. तो ये जो टर्मिनल पे OH है, that will take up H plus. Me3O OH2 प्लस हो गया। अब इसके बाद आप क्या कर सकते हो कि यहां से इस OH2 को बाहर निकालिए, जो कि इस स्टेप में किया गया है। ओके, एंड यू गेट समथिंग लाइक दिस। हाउएवर ये बनता नहीं है, this is not obtained, it is because it is very unstable. So what we do is we show a concerted step, मतलब एक स्टेप में बॉन्ड का टूटना, एक स्टेप में बॉन्ड का मूव करना, हम दोनों दिखाएंगे। So this is positive. If this goes out, then one of these methyls will come over here. 1, 2. Clear? And we will end up getting MEC positive, MEOME. इसमें आगे चल के क्या होगा कि this will react with H2O and it will create MECOH, MEOME. This species will lose H plus, this will come over here, this will go out, and I would say H plus की जगह ये लिख दिया जाए -MEOH बाहर चला गया, एंड आपको एक कीटोन मिल जाता है। ओके, इस मैकेनिज्म, इस हाइड्रोपेरोक्साइड मैकेनिज्म का सबसे इंपॉर्टेंट एप्लीकेशन जो है वो हम ऑब्जर्व करते हैं फेनॉल के प्रिपरेशन में। ओके, वी ऑब्जर्व दिस इन प्रिपरेशन ऑफ फिनॉल। लेट्स लुक एट दैट। उसमें जाने से पहले मैं आपको बता देता हूं कि ये जो माइग्रेशन, अगर मान लीजिए कि 3 डिफरेंट तरह के अल्काइल ग्रुप लगे होते हैं, देन माइग्रेटरी एप्टीट्यूड इज 3 degree alkyl more than 2 degree alkyl more than 1 degree alkyl more than methyl. Okay, let's look at how phenol is created. So preparation of phenol using this method. To prepare phenol we use क्यूमीन, और ये है क्यूमीन, आइसोप्रोपाइल बेंजीन, दिस इज क्यूमीन। ओके, आइसोप्रोपाइल बेंजीन, दिस क्यूमीन। एक्चुअली करते क्या है कि क्यूमीन का पहले हम ऑक्सीडेशन करते हैं। ओके, first and foremost we convert cumene to cumene hydroperoxide. इसको converted to cumene hydroperoxide। और ये किया कैसे जाता है? So Me is a hydrogen. This reacts with a free radical, forms C, which then reacts with O2, and it becomes this one, and then it reacts again with RH, generating alkyl free radical. You can write PHCMe MEOOH. This is the first step of the reaction. Cumene का oxidation आपने कर दिया. After this, you will perform the same hydroperoxide rearrangement. So MEOCH OH, presence of H plus, this will turn into MEC. This one goes out and this one comes over here. The migratory aptitude of pH is more than that of Me, and you get MECME plus OPH. ये stabilize किया जा सकता है resonance से. I'm not showing that. I'm directly showing what will happen next. So react with H2O, remove H plus, MECME OH pH. Then it reacts with H plus, get MECME. And this comes over here, this goes out. We remove a proton. We had added a proton, we remove a proton, and we get MEC double bond O, Me plus pH H. So आपको phenol मिल गया. Please remember that this is a very important reaction, और इस reaction को NCERT में भी पूछा गया है as well as JEE में भी पूछा जा चुका है. Okay, so cumene hydroperoxide reaction is a rearrangement reaction in which a nucleophilic group migrates to an electron deficient oxygen atom. Okay. The last type of these reactions where the migration of a nucleophilic species takes place to an electron deficient oxygen is Dakin reaction. Dakin reaction is a reaction in which an aromatic aldehyde having OH and NH2 at a group ortho or para position is converted to corresponding phenols by treatment with alkaline hydrogen peroxide. आपने लिया salicylaldehyde, H2O2 NaOH के presence में you will get catechol because the CHO turns into OH. Okay, और formic acid आपको मिल जाता है. Dakin reaction is not a very complicated reaction, और इस reaction का mechanism समझने के लिए we have to start from here. You start by taking a hydrogen peroxide और इसको OH minus के साथ reaction कराया, जो reagent आपने लिया, you get a hydroperoxide unit. ठीक है, और hydroperoxide ion. This hydroperoxide ion reacts by nucleophilic addition at the carbonyl carbon HOO minus. This attacks over here, it's up, and you get this. आपको ये मिल जाता है. ओके, अब यहां पे क्या होता है कि दिस O माइनस, प्लीज लुक वेरी केयरफुली, दिस O माइनस shifts its electrons over here. This whole group migrates to oxygen and this one goes out. Okay. मतलब यहां से बॉन्ड ब्रेक करेगा. Okay, you will break the bond from here and this carbon will be attached to this oxygen and you will end up getting something like this. O will be OH. Okay, and there will be C double bond OH. Because it is a basic medium in which the reaction has been done, तो मैं इस OH को O minus में convert कर देता हूं. Okay, so इसको हम बोल देंगे 1,2 aryl migration. There's 1,2 aryl migration. After this, OH minus attacks here. A tetrahedral intermediate is formed. And this comes over here, this backs out. So आपको ये से इस कैटेकॉल का एक anion मिल जाता है. Not a conjugate base. I'll not say that it's a conjugate base because conjugate base and the acid are related to each other by loss of just one proton or difference of one proton. इसको आप further H plus के साथ treat करते हैं and you get catechol. Okay. Clear? इसके कुछ features हैं which are quite interesting. So what are the features of this? First feature is that if there is a OH or NH2 at the ortho position or para position, OH or NH2 facilitate the 1,2 migration, so enhance the rate of reaction. Next, if very strong electron withdrawing group like NO2 is present, at para position, then hydride transfer occurs instead of aryl transfer to give carboxylic acid. इसका बहुत कॉमन सा एक एग्जाम्पल है कि आपने अगर NO2 यहाँ पे लगा दिया and let's say there is OH and then there is CHO and you have used the same conditions H2O2 NaOH and second H3O plus, then you would be getting you will be finding that the CHO will turn into COH. Okay. So there are only these three nucleophilic rearrangements to an electron deficient oxygen. Next class में we will be discussing nucleophilic rearrangements to an electron deficient nitrogen. That's all for today, guys. This is Saurav Goswami signing off. And if you face any query, just let me know in the comment section. Let's meet in the next session. Bye-bye and have